Man, you gotta love early March in Texas. It is great. Left Nashville, came out here, and it was a little cold, but nice and comfortable and all that fun stuff. We are back at Excess Powder Coating right outside of Fort Worth, Texas. Now, I appreciate you guys watching the videos up until now. They finally have their equipment is all set up. It's all wired in. They're getting ready to start to try to go bring some business in and all that. Now, this video is going to be slightly different than the other episodes in that this will be somewhat pieced together. It's not as much where we've been sort of showing you the behind the scenes thing. And as we're wrapping this up with these guys, what we're going to do today is I want to show you what they got as far as equipment goes and explain just a little bit about it and why they did what they did, so you can see some things. So this one, you'll notice this is going to be a little different than the other episodes, and it's going to be sort of snippeted together. But I just I'm going to show you some very important things on the equipment, and again, why they did what they did. And I got to be honest with you, female-owned company, these folks, they're hustlers. And they're already fielding phone calls from larger commercial accounts, and some folks are already bringing stuff by the coat, and they're not even ready to go yet. So there's still some things that they're just wrapping up the last final details. But I have a lot of faith that these ladies are going to do an amazing job. So walk with me through this, and I'm going to show you a few things about what they ordered, why they ordered it, and at the same time explain some things to you about equipment that I think is important to understand. Because I've got a book that's about to come out, and one of the things that we talk about in there is some different things from an equipment standpoint. And it's not about equipment that I build or anything like that. It's just things you want to keep in mind. What's the best way to put this? Let's just call it like it is, right? There are a ton of so-called experts in the powder coating industry who have popped up everywhere. I mean, there's a few folks on some of the message boards that are, like, I've just saw one in the last few days where they're using AI written, it's very obvious AI written content, and then selling their own little how-to things. And I got news for you. AI's never powder coated a single part. Never has. And we have people that are going on the message boards that are experts who, if you really look at their business and whatever, it's a hobby that they're doing somewhere. And I'm not knocking hobbyists. I promise you I'm not. But if you're going to do this and you're going to make money doing it, there's a right way to do it. There's certain things that you need. And a powder coating oven isn't just grandma's old kitchen oven. I mean, it's not. There are certain things in the designs that you really need to look for. If you're shopping for used stuff or whatever it is that you're doing, I want to use this video as an opportunity to sort of point a few of those things out. So follow me inside and let's take a look at what these guys have going on. Okay, so on the controls on this thing, what we do this a little bit different, and this is going to be a big help to them, is a lot of ovens are made with, well, one, they're cool touch screen control panel ovens that are out there. I love them. They're great. And I've had people say, why do you not use touch screens? You do a lot of technical stuff from a marketing standpoint. I know you have a lot of very technical people work for you. Dude, why don't you offer a touchscreen? I'll be dead honest with you. The reason I don't do anything with a touchscreen is if it ever goes out, storm, whatever, if it ever goes out, then it's going to require a technician to restart it. You can get in real trouble real quick with a touchscreen that goes out, and you're trying to reboot it or trying to get something to happen with it, and it's not as easily replaced or whatever. I still like the old school method of parts that you can get tomorrow, because your customers don't care that your touchscreen went out. They just want to make sure that you're getting the parts done. Second point I want to make on that is this. One of the things that we do a little bit different is a lot of ovens are wired so that all the safeties are wired in a loop, and you have to have safeties. You have to have safeties. You have to have safeties. As a matter of fact, I'm going to show you later on this video. I'll talk to you about the safeties. But a lot of them are wired in a loop. The problem with that is if one of the safeties trip and an alarm goes off, now you have to have an electrician with an electrical schematic and a meter to walk from the beginning through each individual safety to find the one that failed. What we do is you have all the faults. So if your exhaust fan, if your belt breaks on your exhaust fan, the exhaust fan will fault. So the airflow will fault. If a belt breaks on a recirculation fan, it's not getting enough airflow, that will fault. If your propane tank runs out of gas and it shuts your burner off, the burner fault light will come on. So you know exactly to walk to the burner, walk to the exhaust fan, walk to the recirculation fan, walk directly to here is where the issue is at. So that's why we sort of do that the way we do that one. I do want to walk right, I'm going to show you right here because they've got their booth control panel hooked up. Here's the thing about a booth that, and I see folks online talk about, I'm doing this without a booth, I'm building my own booth. Here's my only point of advice, and you can save your emails and your comments. I'm just trying to help you. If you don't agree, that's okay, but I'm just trying to help. If OSHA walks into your building with a velometer and you are not reading 80 feet per minute of airflow at the opening of a booth, you will have a conversation that has zeros on it. Period. That's the code. I didn't write the code. It's NFPA 33 and NFPA 86. That are the two that are used for booths and ovens. Look them up. That's the same ones that all fire marshals use, OSHA uses, EPA uses, all codes people use, those two books. What you do better match those. And then I get the argument that goes, well, I'm out in the so-and-so. OSHA's never going to come see me until you piss off a former employee or a neighbor or a competitor that you steal some business from, because all it takes is one anonymous phone call and they will show up at your company or at your garage or at your whatever. And if you're not doing the things the way you're supposed to be doing it, you can get in real trouble. That's the reason I always say our classes and seminars and things that we do are all based around running a successful powder coating business, not how to powder coat and do hobby stuff and things like that. Again, I don't knock anybody like that. Hell, I started out that way. Folks, some of the people that are watching this video that are just beginning, that are broke and whatever, I was you. We built all this. I learned this the hard way, but also learned the right way to do it, and found out very quickly that there was only one path to do it and make money doing it as a coder. And then we got into what we do with the manufacturing and all those things. So I'm not knocking that. I've been there, done that. But I do know that prison is a scary thing, or well, you wouldn't go to prison anyway, but you can lose everything you've got, right, with some of the fines. So just be careful with those things. So, but and where I go through with the 80 feet per minute, what is with one of the things that we do at the booth is we have gauges. So these magnehelic gauges, when they turn this booth on, this is a pressure differential gauge. So the filters inside the booth, when those need to be changed, not cleaned, changed. You can't clean filters, regardless of what anybody tells you. Can't clean them. Think about it, folks. It's a woven material. If I blow through it, all I'm doing is opening up the weaves, letting more stuff get to it, into the more expensive filters behind it. Because your filters, if you have a 3-stage filtration, it's going to be cheap, a little more expensive, expensive. If I blow out the cheap one, I'm just opening the weaves and letting stuff get through the cheap one and the more expensive one. You're just creating a more expensive problem for yourself as you go along. So, rewinding that back, one of the things that we've done is when you get to the, when you need to change the filters, the less expensive filters, there will be a light comes on that says, change your filters. The yellow light comes on. Hey, you're gonna need to change these filters. You're gonna need to change these filters. Well, if you don't change these filters, or it gets to the point where your final filters are starting to back up, Your final filters are the very last one that the air goes out of. So it's sucking air in, blowing air out. If the air can't blow out, it's like me trying to blow through a straw and pinch it. Then it's not gonna draw from this end because I'm closing out where it can go, right? I can't blow through the straw and pinch it off. It's not going anywhere. You can suck through the straw, you suck through the booth, and if it can't go out the other side, it's suddenly not gonna suck out the booth, and we start to lose down and get past the 80 feet per minute. When you do that, about the time you get close to about 190 to 100 feet per minute, this differential gauge is set so that it will equal 3 inches water column, which will then trigger this alarm, and it will shut the booth off, and it will not let you start it back up until that's changed. That's me trying to protect you from you. It's trying to keep you from having that conversation that has the zeros on the end of it. So cool little thing that we put on there to help you from a booth standpoint. So let's walk over and look. I want to show you, so we talked about safety stuff a moment ago. For the oven, I want to talk about the safeties just for a second. So let's go look at this. So these ladies have got a 20-foot oven. This thing is 8 by 8 by 20. So it's 8 foot wide, 8 foot tall, 20 foot long inside. One of the things you want to pay attention to when you are looking at ovens that I've noticed this in a lot of places is you see people say an 8 by 8 by 20 foot oven, but the inside usable space because of venting and things may not necessarily be 8 foot, or it may not necessarily be 20 foot. So you want to make sure of what matters is the inside usable space. So this one is 8 by 8 by 20, which is going to allow them to do car frames. They're going to be able to do some ornamental iron fencing and stuff like that. So walk with me on in here and I'll show you a few other things. Now, the way a batch oven works is what this thing does is we blow hot air down, we draw it back through these vents in the back. It pulls up, goes back through the flame, which reheats it and blows it back in. You'll notice these vents are open. These vents are pointed down, so we're creating an air curtain here, and we're blowing all the hot air down. Now, I will say something about venting in ovens. This is an argument not an argument, this is a disagreement. A difference in philosophy between some different oven manufacturers. Older technology in ovens always had air blow in from the sides here and blow in and up. What we do that's different is we blow it in from the top down. Here's the reason I do that. Listen, I tell everybody this. Don't believe everything you read. Don't believe everything you see. Don't believe everything that you hear. There are a lot of experts, but you're not going to take money advice from a broke person. You're not going to take hairdo advice from me, right? So make sure if somebody says something online, don't believe it. Make them explain it, right? So I'll explain it to you. I'll tell you the very reason we do this. Heat rises. So what we're doing is we're blowing the hot air down. As it's trying to rise, we're pinning it to pin it down to the ground. So we're getting more uniform heat down here and all throughout this cabin. My issue with air coming in from the sides, and we've worked with folks with that work in NASCAR and some things like that. So they have some really cool tools where you can see air, and we've looked at some infrared cameras and whatever. What we found is that with the air that blows out from here, as it comes out, the heat rises, so the hot air comes up, and the first thing it wants to do is go straight up. Now, the argument can be, yes, but if you put enough pressure behind it, you can get it to blow to the middle before it starts to come up. The issue with that is the amount of air pressure that you have to put to get it to come all the way across. Now you can start to blow powder because it's just powder. It's like baby powder, and it comes off, right? So the amount of air pressure that you put in can cause, if it's too much, it can cause you to blow the powder off at the bottom, right? So let's see, what else I want to show you on the inside of this thing. Temperature probes have to have a temp probe that measures about midways of your ovens and about sort of center height and all that fun stuff. Be careful if you have people with temp probes and they're telling you to put your probe at the very top. because now they're just reading the hottest air. I don't care that it's 400 degrees there. I want to make sure that it's 400 degrees everywhere else sort of throughout here. So that's the venting. Let's go talk about something else. Okay, boys and girls, so exhaust fan. This is the exhaust fan on the oven. And by code, we talked about the NFPA code earlier. By code, you have to have an exhaust fan. There are some folks online that are selling powder coating ovens that are, I don't care if it's gas or if it's gas or propane fired, it damn sure has to have an exhaust, because you have the burnt gas fumes that have to go outside. But even if it's electric, it has to, by code, have exhaust. I didn't write it, didn't make it up. It's in the code, go look at it. So a so-called powder coating oven that is on the market that doesn't have an exhaust fan is completely illegal. If the wrong person comes in to see it, again, you're gonna have that conversation. It's gonna be a not real happy one, and you're gonna stroke a check that could be used to build your business, and you're doing it to correct a mistake where somebody's just not telling you. So exhaust fan, talk about a safety standpoint. This is an airflow switch, has to have it. What the airflow switch this is doing is it's reading the air moving through this exhaust stack, because if this fan ever stopped, you'd never hear it. If the belt breaks, you'd never hear it. You would never know it. So what happens is, if we lose airflow going through there, this switch will send the signal to that panel we looked at earlier, and where the exhaust light is at, it would trip that light off. So gotta have the exhaust fan, and you want to have some sort of airflow switch or some sort of sensor, so if this thing goes off, that it will shut it off. So let's look at the one on the recirculation fan. Okay, so we've got the burner on this thing, which is it's all NFP compliant and all that stuff for the NFPA codes. But I was talking about the airflow switch. There's also one on the fans. Now, I'm gonna get my camera person to back up here, and I want them to shoot up. So if you can see, it's going to be harder to see, but you can see this very large fan that is on the top of this. I want to talk to you about fans for a minute, because I have been seeing some things that that are slightly concerning. So I want to make sure, I just want to explain to you about the importance of the recirculation fan and sizing it and things of that nature. So back on me, we will, how's the best way I can explain this? Okay, you can use squirrel cage fans with shafts. You can use different types of fan to move the air. All are okay as long as they move the right amount of air. We choose to use slug fans. These are very beefy. If I could show you the inside of it, and the thickness of it, you can smack this thing with a hammer. You're not gonna, it is a big, beefy fan that moves a ton of air. I like that one because it's in the heat, and I want it to last a long time. I don't like anything that has really thin aluminum fins, and I got to be honest with you, I've never been a fan of shafts that are in the heat, because eventually they're going to work. Sooner or later, especially bearings. Oh my gosh, if there's bearings in the heat, all those things eventually go out. So we try to use something that's not going to do that. But you have to have a recirculation fan. Oh, well, we found this electric oven and it just has heating elements. Common sense, let's talk about that for a minute. If you've ever baked a cake in your oven at home, and you turn the bottom eye on, and you don't turn a top eye on, so you're getting heat from the top and the bottom, and then you burn the hell out of the bottom of the cake and you can't figure out what went on, it's because you're not letting it heat uniformly throughout it. There's a reason that convection ovens are very popular in industrial kitchens. If we have a big room and we have electric heating elements here and we're not circulating that air, it's hot here. And the further away from here I get, the less hot that it gets. So I get hot spots and cold spots. I burn and overcook some things, I undercure some things. I've got to have something to circulate that air. Here's the thing that I'm seeing online that concerns me. I just saw a customer in the Carolinas, and I'm not going to call out the people who built this thing, and I'm not going to say the customer's name, but they had purchased an oven from someone else. And they had one of theirs and they had bought one from us. And the guy said, man, here's what I learned when I did this is I bought the first one from these other folks because it was like $7,000, $8,000 less expensive. And later I went somewhere and saw one of yours and I realized why it was $7,000, $8,000 less expensive, because it's got a burner that's a $7,000 less expensive burner. It's got a fan that's $4,000 less expensive. It's got control panels that don't have all the stuff in it. So, because let's just be honest, it doesn't matter who of us that builds a 20-foot oven around the country, we're all using the same amount of metal, and none of us are getting a greater deal on metal than anybody else. I mean, we get a pretty good deal because we sell a bunch of ovens and booths, like multiples per week. But nobody's metal prices and all that are going to be that much different than anybody else's. The cost to manufacture is kind of the same for all of us. When you start to see things that are really inexpensive on one end, when a lot of other people are here, there's a reason. You need to go back and look at the other components, the fans and the burners and the controls, because that's where the money sort of comes in at. So what I noticed and he told me this, and I was like, wow. So got to make a few phone calls and asking some questions, and started looking at the CFM inside the oven. So let me explain to you. I'm going to give you a little hidden piece of information that a lot of oven people won't necessarily tell you of how they do it, right? But I'm going to give you the secret sauce here. If you take the cubic foot of the inside of an oven, so this oven is let's say it was 8 by 8 by 10, because this is going to be an easier math. So 8 times 8 is 64, times 10 is 640, right? So if you have 640 cubic feet on the inside of that oven, you really want to turn that air over at least 3 times a minute, preferably closer to 4. And you can go sort of up to 5. You don't really want to, you start getting over that. We're starting moving too much air. We're going to start blowing powder off. But 4 is sort of like the really hot spot to be at. 4 turnovers a minute. So what is a turnover? A turnover means that 640 square foot of air is replaced 4 times every minute. And the way you do that is you take length times width times height times 4. That gives you the CFM of the fan size that is needed to turn that air over that many times. So this 640 square foot oven, to turn the air over 4 times, I'm trying to do the math real quick. So that's what, 160 plus 2,400 is 2,560, I think. Somebody I'm sure will correct me in the math if I'm wrong at the bottom. So that needs about a 2,560 CFM recirculation fan in order to turn that air over 4 times. I've started doing the math on, I've seen some quotes lately for some of the guys out here that are selling some things and that are really just, on some of the message boards, like, oh, I got this really, really inexpensive here. And I've reached out to them, like, hey, can I see the specs on this thing? And I've seen things that show 1/2 of it. I literally did the math last night on one that it was 0.5 air turnovers in a minute. 1/2. So they saved money on the fan. They saved you money on the fan. saved you a couple $1,000s, $2,000 or $3,000, $4,000 on a fan. And that's all great until you have $20,000 worth of rework or what, because you cannot produce a top quality part that's going to last a long time if you don't have the right amount of air circulation, because it's not going to cure right. It's going to undercure and overcure, and it will create quality problems. You have one chance to make a good first impression with that big industrial customer you're going to go try to get. The first time you start putting out garbage, it's that telephone, telegraph, tell a customer, because they're going to tell everybody. You may not see them post online about all the great things you did for them. Screw something up and let me know how fast it happens that word gets around that you create poor quality. And it's not always your effort that you're putting into it. It's the products that you're using. Not necessarily, listen, I'm not going to stand here and say that we build the only oven that works in the United States, because we don't. There are some very reputable companies that do it. There's also some very not reputable folks that are putting some things out there that I'm saying just watch those, because sometimes cheap is cheap for a reason, and just be careful with that. And the powders that you use and the chemical, use the right chemicals, use the right powders. I promise you, you do those things, you will be successful doing this. So I appreciate it. I'm about to get out of Texas and unfortunately fly my rear end back to Nashville where it's cold, but come visit us. Hey, look for my book on Amazon, the powder coating playbook will be out. I think it's they're finishing up the title stuff on it, but look for that book on Amazon. It should be out any day now. And yeah, check out our classes. I'll have them post a link in the to our classes below this video, so come check that out as well. And we look forward to seeing you the next time. Next time I'm going to come back out here. I'm going to give these folks a few weeks to get up and running, and then we'll come back and check on them and see how their marketing and all that's doing once they get going. So we'll see you on the next episode.